Between March 15th and March 18th of 2023, something insane happened on the surface of the sun. A plasma tornado, which looks absolutely ridiculous. But not only that, on April 27th, 1999, the Hubble Space Telescope pointed its lens towards Mars and saw this: a Martian hurricane.
What?
Technically, it wasn't a hurricane because, it's not a tropical cyclone. You kind of need an ocean, and, we don't need to get into vocab words, but it was a cyclone of some sort. I mean, look at that eye. In fact, this thing measured over 1,000 miles wide, and the eye was 200 miles wide. Put that on Earth. You want to see what that looks like on Earth? Yeah, absolutely massive. Oh, and did you know that throughout history, many people have claimed to have seen lightning flashes on the moon? What the heck is going on? Well, that's what we're talking about in today's video on solar system weather. Welcome back to the channel. We're going on a journey talking about every single planet, but before we get to those planets, let's actually start off with the sun. When it comes to the sun, most don't really think about weather. In fact, many don't even realize the sun has an atmosphere. But it does have an atmosphere, and it's massive. The sun's atmosphere is broken into several different layers, starting off with the photosphere, followed by the chromosphere, and finally the two outermost layers, the corona and the heliosphere. The heliosphere is so large that it actually stretches out into interstellar space. Now, what's interesting about the sun's weather is that it impacts the entire solar system. This is why scientists prefer the term space weather over solar weather, as the sun's weather doesn't really stay within its boundaries but actually gets shot out all over the solar system. Solar storms include both solar flares and corona mass ejections. This is when the sun shoots out massive bursts of plasma and particles. And if these storms are directed towards Earth, they can cause a geomagnetic storm. Geomagnetic storms are the result of solar winds interacting with our magnetosphere, and that's how we get beautiful auroras. Large geomagnetic storms can actually pose a threat to our well-being. In fact, on September 1st, 1859, a massive solar storm hit the Earth in what is known as the Carrington event. Telegraph wires were fried, auroras were seen as far south as Mexico. If the Carrington event happened today, it would do all sorts of damage to our electrical systems. Satellites would be damaged, communication systems would go down, there would be blackouts. It would not be good. And this actually almost happened in 2012. There was a massive solar storm and it just barely missed us. So we have solar winds and we have solar storms, but let's go back to solar tornadoes. From time to time, solar tornadoes have been known to crop up on the surface of the sun. In March of 2023, a massive solar tornado formed towards the sun's north pole. The height of this tornado was 110,000 miles, or about 14 Earths, which is insane. This footage just is amazing to me. First it starts off and there's some disturbances, there's something going on, and then all of a sudden it just takes off. It's such a sweet piece of footage. Speaking of tornadoes, Mercury also has tornadoes, but not the kind you're thinking of. But before we get to said tornadoes, let's just take a quick look at Mercury. Yeah, not much is going on in terms of weather, considering it barely has an atmosphere. But scientists did discover an interesting tornado-related phenomenon. Like Earth, Mercury also has a magnetosphere, but Mercury's magnetosphere is weak. So weak that sometimes it has massive holes. These massive holes spiral down to the surface of the planet and take on the appearance of a huge magnetic tornado. These magnetic tornadoes expose Mercury's surface to the solar winds, so you wouldn't want to be chilling in, the eye of one of these tornadoes. Not that you'd really want to be chilling on Mercury in the first place, considering the surface temp on the dark side is negative 290 degrees Fahrenheit, and on the day side is 800 degrees Fahrenheit. I don't know if you could find a sweet spot, in the shaded area, kind of on the edge of the day and night cycle. You can find a perfect temperature there. Probably not. We're moving on. Now, Mercury didn't offer much in terms of weather, considering it has no atmosphere. But our next planet, Venus, has all sorts of insane weather. The climate on Venus is not fun. Surface temperatures are around 900 degrees, and the atmospheric pressure on the surface is about 90 times more than Earth. Not an ideal place to hang out. In fact, the planet is so inhospitable that the Soviet Venera probes, at best, only lasted for a couple of hours, which is actually pretty impressive considering how extreme the environment was. Do you want to know what it would sound like to be on the surface of Venus? Well, fortunately for us, The Soviet Union's Venera 14 actually recorded its surrounding environment. Take a listen. The clouds on Venus are quite unique, as they are mostly composed of sulfuric acid droplets. Venus also has acidic rain. It wouldn't feel good. The clouds on Venus look very similar to towering cumulus clouds here on Earth and cover almost the entire Venusian surface. They are also highly reflective, which is why Venus is so incredibly bright in our night sky. The only objects in the night sky brighter than Venus are the sun and the moon. And I guess, technically, the occasional great comet. And I guess if Betelgeuse went supernova, or if there was a supernova, that would be super bright too. But you know what I mean. Perhaps the most interesting weather anomalies on Venus are its two polar vortices. These are double-dyed hurricanes at both poles that were first discovered by the Pioneer Venus Orbiter in 1979. They were confirmed in 2006 by ESA's Venus Express Orbiter. So what causes these polar hurricanes? Well, while Venus itself rotates extremely slowly, only about once every 117 Earth days, the atmosphere whips around the planet once every 4 Earth days. The disparity between the atmosphere rotation and the actual planetary rotation is the likely culprit for these polar vortices. Now, there's actually a sweet spot in the Venusian atmosphere, about 30 to 40 miles up, that could be very nice for human habitation or for life in general. You'll find that temperatures are very comfortable. The atmospheric pressure is very similar to what it is here on Earth at sea level. Gravity is similar, and you even get radiation shielding from the thick atmosphere. You wouldn't be able to breathe. But who needs to breathe? Just put on a pressure suit. You can build another cloud city. It'd be sick. Next up, we travel to Earth. We're here right now. If you want to know more about our planet's weather, you can just look at any of my historic videos. But quick shout outs to hurricanes, derechos, which are like land hurricanes, tornadoes, all sorts of cool stuff. But we're going to move on to the moon.
I found the easiest way to talk to your pets.
Have you seen my ball? I am hungry. Please feed me. Mommy, please pet me.
Download it now and try it for free.
The moon doesn't really have much of an atmosphere, so technically there's no weather on the moon, right? Well, flashes of light have been reportedly observed on the moon for centuries. These flashes of light are known as transient lunar phenomena, or TLPs, and they were even reported 1,000 years ago. One of the early reportings happened on June 18th, 1178, when 5 or more monks from Canterbury reported some unusual activity on the moon's surface shortly after sunset. Quote, "There was a bright new moon, and as usual, in the phase its horns were tilted toward the east, and suddenly the upper horn split in two. From the midpoint of the division, a flaming torch sprang up, spewing out over a considerable distance fire, hot coals, and sparks." That sounds pretty dramatic. And there have been many reports similar to that throughout the decades. Now you might be thinking, wow, if there's all these flashes on the moon, shouldn't we have a video of it or something like that? Well, actually, we do. In February 2023, a Japanese astronomer by the name of Dachi Fuji captured this video.